I wish to assure you I'm not a networking expert. I'm a programmer. My name is Bryan Boreham. I have worked on a certain network product. This is the one advertising slide. Really what we do is monitoring and CI/CD tools and things like that. So weave.works, if you want any of that. It's all focused on Kubernetes, so it's really cool. What am I going to talk about today? I'm going to talk about the exact same stuff that Michael talked about. I don't know why he didn't read the agenda, but I'm going to do it with pictures instead of command lines. So hopefully that appeals to different people in the audience. I help a lot of people out, at least I think I do, on the Kubernetes Slack, like SIG Network. I'm getting a lot of blank looks. Okay, so there's nobody here that I've personally insulted on
Not yet.
on the Kubernetes Slack. That's good. That's good. So yeah, really my main aim is a selfish one. I want to give you enough knowledge that I don't have to repeat the same explanation over and over again on Slack, at least for the 70 odd people in this room. There are some words on the screen. We'll get to those words. Okay. Show of hands. I think we did Kubernetes before, but I was at the front, so I didn't see. So who's like kicking the tires? I heard the name. I ran it once. Couple of people, maybe a couple of people. Who's full on? Everyone's full on. Okay, so you don't really need this, right? You know, no? Show of hands. Who's heard of my employer? And yeah, oh well, lots of people. Okay, okay. So I wanted to put up. This is the high level picture. This is really what Kubernetes is. For those of you who know this already, I apologize. I'm going to go through. Oh, maybe not that diagram. I'm going to go through. Maybe I'll go quite quickly, but just to make sure we've got all the words and all the concepts down. So the basic idea is Kubernetes is going to run some work for you. The work is the light blue bits. Kubernetes has this thing called master, which is the thing that knows everything, has all the facts, and it's running some software on each of the nodes. The nodes are computers. Those are the things that are actually executing your work. You might have one of those, you might have 1,000. The bit of software on each node running bits of Kubernetes, bit of software in the master that has all the facts. That's Kubernetes. Kubernetes runs services. What is a service? Service is something that does something, and you can call into it. You can call into it from somewhere else in the cluster, or you can call into it from outside the cluster. Get all the words straight. Take a little segue into ports. Everything runs on a port, right? Who doesn't know ports? So if you want to run two of the same things, you can't run them both on the same port, right? So what people typically do, they pick a different port number, maybe 9090, 9091. Great. Problem you've then got to solve is, let's add some tech here, so I don't have to walk around so much. Any cats in here? Sorry. The problem you've got to solve, anytime you've got someone making a call into your service in this kind of environment, it has to know which port to use. And people solve that problem usually with some kind of service registry. They put them in some kind of database, they look them up and so on. The downside of that is every bit of software that you want to call into this environment has to understand this relationship, where you stored the ports and how to look them up. And that's a non-standard thing. There's no, you can't expect any random bit of software to be able to do that. So that's a bit annoying. So first thing we do, we give every service its own IP address. So people write blog posts called things like, "There's no such thing as container networking." And I think, what have I been doing for the last 3 years? if container networking means nothing else, it means giving each of your containers its own IP address. And now we can use the port number that was baked into the thing in the first place. We don't have to go changing the port number. That's why we do this, right? This is the big feature. Give every service, every instance of the service, its own IP address. OK. Now, the problem we had earlier, which port do I use, now becomes which IP address do I use? OK? Oh, hang on. I'll come to that in a second. Let me just make sure we got some more words. Pod is a collection of containers. Container Docker whale, a collection of whales is a pod. OK, that's where we get that from. The IP address in Kubernetes goes on the pod. So we collect a bunch of containers together and put the IP address on the pod. And we saw node earlier. Containers are inside the pod. OK, go fast. Right, yeah, so what I was saying, how do we find the right IP address? Well, it turns out there's already a way to do that, which is called DNS. So this question, which was a real problem a couple of slides back, is now easy, because every piece of software in the world can do this. In fact, it doesn't even do it. It calls into a library. It just says, give me the address of a thing called foo. And underneath, somehow, it calls DNS. So, so this thing that was a problem is no longer a problem. OK. Now, add scaling and redundancy. So we got not just one of these things. We got multiple running. And so we set ourselves a basic requirement. When I'm calling into this thing, I want to hit one of the endpoints. I want to hit one of these, and I don't care which one, because they're all replicas for redundancy or failover or scaling or whatever reason I did that. So that's my basic requirement. I'm going to start here. I'm going to call one of these things. I don't care which one. DNS can do that. Who thinks DNS can do this? Even though I've got a slide up that says it can't. we've got some hand waving. So the kind of boring reasons why we don't do this are the first two. Let's go back to the Tom's taking a picture.
Smile. That's perfect.
So the kind of boring thing that can happen is this guy is going to query DNS every time it wants to make a call. And if you start doing thousands of calls, that's kind of annoying. That's kind of painful on your DNS server. The worst thing that happens is somebody decides that's expensive and caches the result. Looking at you, Java.
Still the default, right? Still the default.
Well, the default up to Java 1.6 was to cache it forever.
Forever, yeah.
And then somebody said, well, maybe that's maybe forever is a long time. So, but yeah. So if we have this requirement that for failure, like if one of these things dies, I'm going to go to another one. And if I've looked it up a few seconds ago and I've cached the result, I'm gonna still go to the one that just died, and that is a real problem. So we don't get a great result out of using DNS for that particular purpose, and there's a third thing that goes wrong. And if you want to know the details, Google DNS happy eyeballs. I am not making this up. There's a really deep, intricate, technical reason why it just doesn't work. And lots of people will argue with me about that one. Maybe let's do that over a beer later, but just doesn't work. OK, so Kubernetes does not do that because it just doesn't work. And because Tim Hockin is a god, and he knows these things. What Kubernetes? So everything I did from let's talk about ports is generic up to now. Now I'm back in Kubernetes. Nothing that I said about ports has anything specific to do with Kubernetes. I'm just motivating this. Okay, so Kubernetes does a little two-step dance instead of all the other things I said you could maybe do. In order, I'm kind of blocking out the light. I mean, let's go back to the cat thing. So in order for my client to reach my service, the first thing it does is says, where's that service? Because all it knows is the name. It just knows foo. And what it gets back is fake news, fake IPs. It gets back an IP address that does not exist. It exists only in the mind of Kubernetes. So this is called a service IP or a virtual IP. And if you call it a cluster IP, then you'll get confused. But that is sometimes what Kubernetes calls it. Let's not worry about that. So first of all, we ask kube-dns. We get this address. We start talking to that address. Our bit of software here, it just totally believes that fake address. And then this other bit of Kubernetes, which is called kube-proxy, sets things up. So there's a mapping to the real pod address. OK? So that's how services work in Kubernetes. Couple of points of detail. So first of all, every single piece of Kubernetes is replaceable. In general, I am talking about the most common way that people run things. If I make any specific statement about a piece of Kubernetes, it's always false in the sense that you could have taken your Kubernetes and replaced that piece that does that with a different piece that does it differently. So the most common way that people run this, it works like on the picture. It could be replaced. Another thing that is really important or really interesting, really good to remember, this mapping takes place on the client side of the conversation. It takes place on this node. That is useful when you're trying to debug this thing and trying to figure out where your network traffic went, where the packets went, whatever. This conversation will get mapped to the real address before it leaves that node. OK. Any questions at this point? It's all gone deathly quiet. Yes.
I'm wondering, how does the virtual namespace of the virtual IP addresses and the real IP addresses don't clash?
OK, how do we arrange things so the virtual addresses and the real addresses don't clash? Well, there's two settings. One of them is the service sider, and the other one's the cluster sider. Cluster sider means the pod addresses, which is why I said don't use the term cluster IP, because it's for service, because it's a confusing thing to use. Sorry.
Yeah, so when a pod wants to do an actual DNS resolution, it will never get back a Kubernetes IP address or a cluster IP address.
So this is what happens if a pod does a name resolution for a Kubernetes service. If it does a name resolution for something like google.com, then that'll get bounced up to the upstream DNS, and it will get the right answer back from there. It only applies to Kubernetes services within the cluster.
Clean your mess. We have a visitor coming up.
There you go. You've been told.
Hi, we got a question over there.
I did a lot of U-card, which is similar to VRP.
Okay.
We have this principle of floating IP address.
Okay.
We have app tables.
Did you miss the part where I said I wasn't a network expert? I have no idea what you're talking about. Sorry, I have a little idea what you're talking about, but what's the question?
My question was, is it based on the same principle, or is it?
Right. So this is exactly the way it works. kube-proxy sets up IP tables rules that map this address with plus the port, which I've just left off the slide, into this address. So that's all. It's done in a kernel module in Linux called netfilter, which is controlled by things that we all call IP tables rules, and that's how it works in the most common implementation.
But the pod always sees the cluster IP thingy, right? It never sees the actual IP.
The calling side sees the virtual address, yes. The destination side believes its own address. It's kind of weird.
How does it do round robin then?
Oh, let's see if I get to that. I can't even remember what's on my slides. So let's see. Hold that question. I did not get to it. Okay. So how does it do round robin? So basically what happens, if there are more than one of these endpoints, then it will put in rules such that the Linux kernel netfilter will pick one of the endpoints at random. I sort of have a temptation to actually show you some of those rules. That's a really dangerous thing to do, is like live demos in the middle of a yeah.
That's the point of you guys. You get to.
Does this thing work? Yeah, I don't know if it's working. I think I'm a little suspicious of the network right now.
You got a
Which network are you?
Which network am I on? I am on. That's the good one?
Yep.
Okay. Connection to my Google Cloud Shell has gone. Well, let's carry on with the slides and come back to this and see if it worked at the end. Oh, it said it did something. Did my other thing do anything? No. Okay, never mind. Okay. You. Yeah, sure.
So the only way that this could scale, so not every node is going to, so any node, if any given node can talk to any given node within your deployment, you can end up having a huge number of IP table rules distributed across out.
Yeah. So for the
would be crazy.
For the benefit of the recording, you're making the point that if we had a lot of services and a lot of endpoints, then this guy would be writing out thousands and thousands of IP tables rules, and that is correct. And that is why they're replacing this with a different implementation. But as of right now, the most common way that people run this, it really does write out all of those IP tables rules.
There's a great talk by Quentin Hall, KubeCon Berlin. He talked about that. Huawei did that. So look it up on YouTube.
Okay. Well, yeah, more.
So this service IP is virtual IP.
Yep.
Yeah. It's not routable IP. It's just exists in IP tables.
Yep.
It exists in etcd. So service or pod on node A, for example, asking for service which exists on node B, and gets this IP in answer. How he knows how to route packets to this node B?
That's my next slide. So yes, as you've just outlined, I was glossing over the fact that we've got packets. If we have a network conversation, we're going to have packets. We've got packets that start here and packets that end up here. And how do they get there? Well, they have to get there somehow, is the simple answer. And there are like dozens of different ways to do this. So I'm going to talk about the two big choices, and then talk about the way that every other choice is covered. And if I still didn't answer your question, then come back to me. Yeah. So this is the question. This is your question, right? Yeah. How do we do that? What is this magical, cloudy, smoky stuff in the middle? What am I smoking? Right. So the big divide in how you do this comes down to this question. What is the relationship you have with your network people? This is my, I wake up sweating, and this used to be my relationship with my network people when I worked for a big company. So if you have a great relationship with your network people, or you built the thing yourself out of iron, or you rented the whole thing from a cloud provider that lets you do this, what you do is you program your routers to send the packets. That's it, right? Now, it does require that you can set up those, it does require you can set up extra IP addresses per pod. Some corporates have a IP address space that's so congested they couldn't actually do that. You couldn't set aside 1,000 extra addresses just to kind of do Kubernetes.
Those are service IPs?
No, these are real. The ones beside the blue squares are pod IPs, and the ones beside the black squares are node IPs.
Okay,
So these are the machines. There's no services here. The service to pod mapping is done before it leaves the machine. That was that picture, right?
Yeah, but how node A knows?
Well, let me answer it, right? Let me answer it. So, so if you have the rights to program your routers, because you bought the network guy a lot of beer or something like that, this is not coming out very. It's not coming out very good contrast. But a typical way you do this is you set aside a range of these IPs on each host. And then you just literally have a list of routes in the router, saying, well, if it's in this range, like 256 addresses go to this machine, next 256 addresses go to that machine, next 256 addresses go to that machine. That is how a lot of people do pod-to-pod networking. The packets actually go on the same network as every other packet. I mean, this is kind of there is no such thing as container networking. Because we just put them on the same network as the hosts. The one kind of tricky thing we did is we programmed the routers to get to the right machine. So we know if the address is in this range, it must be this machine. And Kubernetes has a certain set of components built into it that actually automate some of this, like if you're adding and subtracting nodes. Is that helping? Yeah, helping, good. Question at the back.
So this is all starting to feel very hard. To what extent would IPv6 make this an awful lot easier?
To what extent would IPv6 make this easier? So IPv6 takes away the problem that you run out of IPv4 addresses, because there's a lot of them.
No need to NAT.
Well, there's no NAT on this picture.
You are talking about single collision domain, like single layer 2 network, where
Well, yeah, in IPv6, there's enough bits to do this over the whole planet. So generally speaking, nobody has enough IPv4 address space to do this planet-wide. So they do end up natting, but there's no NAT on this picture. This is just very, very simple, just routing rules. So yes, IPv6. I mean, you just do exactly the same thing, except the numbers are longer and they're in hex and they have more colons in them, and that's the main difference in IPv6. Kubernetes right now does not support IPv6 very well, and I can extend that answer later, after more beer. So almost everyone is running Kubernetes. You know, I said like I'm going to talk about the most common way that people do this, and every single thing I say has exceptions. So that's another one. Okay, so this is if you have a great relationship with your network people and you have the IP address space, then this is an excellent way to go. The other way to go is what's called an overlay network. So what happens in an overlay network is you take the packet on its way out of the machine, you hide it inside another packet. It's just called encapsulation. These things are capsules. I spent minutes looking for clip art.
That's how it looks like.
You could have at least rotated that.
Yeah.
I spent minutes cutting and pasting. When you're using an overlay network, you encapsulate the packet. So things like Flannel, things like WeaveNet are overlay networks. They do this. Overlay networks mean you never have to talk to your network guy because you're actually running another network in software on top of the real network. And hope they don't catch you if they're actually serious network people, because they don't like people running their own networks on top of the real network. So that's overlay networks. There's a little bit of overhead as we do the wrapping up and the unwrapping. There's certain benefits, like these things could be, like one could be in your laptop and one could be in your data center. It doesn't matter. We don't have to be able to program all the routers in between. As long as this machine can reach this machine, the overlay will take care of the rest. We have a question.
It's strange that you haven't mentioned VPN, because that's...
Well, yeah, it's effectively that's what VPNs do. You need the automation to assign IP addresses to containers to be able to create and delete these things 100 times a second. You need a certain set of tooling over and above what something like OpenVPN would do straight out of the box. But yeah, it's basically the same technology. All of this stuff is implemented in the Linux kernel. We make careers out of exposing it in easy to use ways. Okay, overlay networks. Right, now, so I said there's two main ways that people do this, and then there's another 50 ways that people do it. Somebody told me this is the initials of the Spanish, like the equivalent of the CIA, which I find, yeah, I find that very very cool. I'm gonna.
Makes you the kind of like leader.
Yeah, it makes me the James Bond of packet encapsulation. How am I doing for time, by the way? I'm nearly finished. Am I okay? 5 minutes. Okay, let's go. Yeah, CNI. So CNI is a API for writing plugins so that Kubernetes does not need to know how your network works. So if you have a network technology that is special in some way, all you need to do is write the plugin. Kubelet calls the plugin. It sends it very simple commands like add and del, and the plugin wires up the pod to the network. That's the purpose of meaning of CNI. That is that. Okay. In the next part of my talk is about exposing services outside of the cluster. And I'm not going to get into all the detail in 5 minutes. Let's spend most of the time on this one, because everything kind of builds on this one. What is a node port? Node port is the sort of the default kind of service you get if you don't say you want any other kind of service. If you want to expose a service outside the cluster. Kubernetes, if you get a node port, it will arrange things so your service has a funky port number like 30,021, some high port number that it picks to try not to clash with anything else. And you can call it on any machine in your cluster. That's the meaning of node port. It's on every node. It should be like nodes port, but Kubernetes has a problem with plurals. So, if you hit a node where the service is not running, it will bounce it across. It's all done with IP tables rules. In fact, by default, it will bounce it across even if you are running one on this node randomly. The default implementation is optimized for fairness, so it'll just go bouncing across your nodes willy-nilly. That's node port. Okay? Host port is exactly the same thing, except it doesn't bounce across machines. it's implemented, well, yeah, so host port in the beginning is implemented by saying -p to Docker, whereas node port is implemented in kubeproxy. Whoops. And this is what the documentation says. Do not use host port.
One machine, right?
Well, yeah, it maps it on whatever node your pod is running on. So yeah, you'd have to know which pod it was running on, or you have to do it for a daemon set, which is running on every node, or something you'd have to use like labels or something like that to tie it down to one. Yeah, that's sort of follow those instructions. Hi.
When is it absolutely necessary?
Let's go on. No, I'll come back to.
If you want to reduce latency,
I'll come. Load balancer. You can request that your service is a load balancer, and really what that means is you've got another piece of kit somewhere that is a load balancer. So if you're using Amazon, that's going to be an ELB. You know, could be a box or like a F5 big IP device. Could be Kubernetes is going to program your load balancer to do the right thing. The right thing is going to be to come into the nodes, and then it actually uses a node port to bounce across to the machine it's really running on. So the important thing to remember is load balancer, there has to be a specific bit of kit. So if you're running at Google Cloud Platform, it's going to be a Google load balancer. If you're running at AWS, it's going to be an ELB. This is a layer 4 for those of you who are listening in college. And finally, Ingress, which is kind of the same thing, but layer 7. So it's completely different. And again, specific implementations. So there's an Amazon one called an ALB, or you can run an Nginx. In this case, it's going to run inside your cluster if you're running like Nginx. And in that case, you would expose it with a host port. Where was the question? Yes. This is where it's absolutely necessary. Because of the because we know where the Ingress controller is running. So let me just show you the config for an Ingress controller. I just want to highlight. So it's all about HTTP. You can route different paths to different services. It's totally layer 7. It's all based around receiving the request, parsing the request, forwarding it on. Which is done in something like Nginx, which is a reverse proxy. So it's really a completely different animal to a load balancer, which is layer 4, which is like TCP only. But they're kind of conceptually the same thing. Okay. That's it.
Yeah, so for the Nginx part.
Yeah?
Isn't really, so you can only have one phone, or
Whoa.
you need to have another load balancer balancing your Ingress?
Yeah, so if you could have some kind of more complicated arrangement where you had like an ELB coming into your Nginx or something like that. Yeah, I mean you can string these things together however you like. This is what I'm trying to say is if you write a YAML specification like that, and your cluster is set up to run Nginx, then you'll get something like that. So yeah, you can layer more things on top of that. You can put things in front of each other. You can chain things together and so on. But that's these things are abstractions, and they can be implemented in different ways. Yes. The last slide. This is the last slide. The previous slide. The other previous slide.
Just to confirm this, I understand this a little bit. So you have an external client that wants to connect to the foo through the Ingress controller.
So the external client will know nothing at all about foo. The external client will see a presentation of an address of the cluster. The external client will be if this is Nginx, it will be talking to a real port on a real machine.
the way I set up an Nginx control is like a daemon set. The Ingress controller writes a configuration for an Nginx, so it's like a very big configuration port. So the outside traffic goes to the host port.
Yeah, it's mapped onto the
And
outside of the machine through a host port.
Internally, it will look at the configuration, not go through the service, but go directly to the source. So there's like this full bar, it lives on this and this and this and this port. So as soon as that one of those ports disappear, the complete Nginx configuration file is being rewritten.
Maybe it helps to
That's
say
sort of-
that there is the controller, which is Nginx, and then on the next slide you have the Ingress resource that actually configures Nginx to route it to the right place.
Yeah, so there's a whole series of things going on. So that document would go into the master. The document is read by the controller, which then, as you said, writes out an actual Nginx. That's what I'm saying. There's a specific implementation which is Nginx, or you could just not do that, and you could use the specific implementation for ALB if you're on Amazon, or you could use the one from Google. You know, the details are abstracted. Ingress it turns out, is a terrible abstraction, because the reality is these things have a lot of overrides and specific rules that only work in one implementation. But don't get everything right first go. So that's what it is. It is what it is.
There are a couple of alternatives as well. Like there's one Ingress controller, I'm not exactly sure which one it is, that has their own Ingress definition.
Well, that's what I'm saying. They pretty much all have their own Ingress definition, even though this format is standardized.
No, but I'm
they
saying
all
they even have a separate, like they have a CRD to define their own Ingress.
right. Yeah.
Basically, it's an automated reverse proxy.
Yeah, conceptually, this is a way to request an HTTP reverse proxy without saying exactly how you're going to do it. And that's kind of the point. That's kind of the principle of Kubernetes. You know, like I'm going to request that some work gets done, and I'm not going to say exactly how it happens. That's the whole point. Oh yeah, we're hiring.